Morning, folks, and a lovely sunny morning it is too. I hope you're getting some fresh air if you can. I'm responding to a request to have a look at rates of change, which I think is the hardest thing I put on this week. And we'll have a look at question 1 and look at a little trick for question 6, which has got a particularly tricky integral. So this is question 1. We've got a tank and we've got a differential equation that we're going to form from that one. Sorry, that's question 2 as well. So we're just going to look at question 1 for now and see what's going on there. So rates of change. We have a cylindrical water tank and we have the rate of flow. So we've got dimensions of the water in there. We could work out the volume of water in there, so just by looking at a cylinder. So its radius is 3 meters, so its volume will be pi r squared times the height, and the height is varying because it's the level of the water in the tank. And we've got water flowing into the tank at a constant rate, and it's got it leaving the tank at a constant rate, but that's if we look at the units of that, it's meters cubed per minute. So these are going to be our units that we'll stick with for this whole problem, but what this is with the meters cubed, what they've actually given us is the volume's rate of change. So dV dt is the increase of volume over time. So that the increase is flowing in at 0.48 pi, but it's also, when this tap is turned on, it's flowing out at 0.6 pi h. So this is its total kind of flow rate, and that's meters cubed per minute. And you'll notice the rate it's flowing out is proportional to the height of the water in the tank. So it is about, that's realistic. You know, the more water you've got in the tank, the faster it's going to flow out, just due to the pressure. Okay, so we've taken all of the numbers out of our problem here, and what they're asking us to find is an equation with dH dt in it. So dH dt, I'm going to have to change variable from v to h. So if I start off with my dV dt, remember with these differentials, and we should be able to cancel out. So we want the dt, but we want to get rid of the dv and turn it into a dh. So just think what the missing fraction is that we need here. So this is what I need to find, dv dh. So to find this, well, somewhere in our question is a piece of information that we have. This bit here, dv dt, we know, and dh dv we don't know, but we do have this thing here, this relationship between volume and height, because we know the tank with diameter is 6 meters. Okay, so let's see how this helps. Well, what this does give us is we can find dV dH quite easily from this. A bit tricky the other way around, but dV dH is just going to be 9 pi times h here. So actually, as a differential, that h to the power of 1 just becomes constant. So it's got a constant relationship, dVh. And what that means is dH dV, remember we can flip them as well, so just like fractions, if I put this down here, dH dV is just the same thing upside down, 1 over 9 So we just flip the fraction to the reciprocal. Okay, so let's plug this all back in and see what we get. So our dH dt is dv dt, so this thing, space here, and pen, back to the one that worked, is 0.48 pi minus 0.6 pi h times this thing here. Yep, so times 1 over 9 pi. So I think what will happen, basically we can multiply it through minus 0.6 pi h over 9 pi. And all they've done is manipulated that a little bit to get it into the form that they've got. Kind of on the home straight here. If I were to divide through up, multiply 100 if I wanted. There's a bit of mucking about here. If you do get stuck on this bit and you've just done some of it, maybe you've done this and got stuck with this bit, do try to get there, but don't waste too much time on it. Instead, try have a go at part 2, which I'll put up as well. And this should eventually cancel down a bit and we'll get something nicer. I think rather than multiply by 100, you can see they've got 75 there. So you see what happens when you multiply them and see what you get. And I would imagine you get, well, these pi's all cancel out, don't they? I would imagine you get the 4 minus the 5h that you're looking for. So have a go at that with the calculator. Part 2 coming up. So like I say, these ones are often split. If you can't get part 1, you're given the result. Have a go at part 2. Don't waste too much time if you are getting stuck here. Okay, see you in a moment.